Okay, well, hello everyone, welcome to this video, and in this video I'm going to finally show myself being alive. That's kind of, yes. So yeah, I'm going to show something kind of new to me. It's a calculator, but it's not a generic calculator, not just any calculator. That's a BCD calculator. So you know how generally you have a calculator which uses like, well, the scary look ahead, but it doesn't matter. Just your good old binary logic. You know, you have one binary number and the other binary number, and just add those together, and it just kind of works. And it's good to have binary numbers. It's pretty quick. I mean, this thing is very, very fast. It's like taking 2 ticks, or 2 or 3 ticks to calculate the correct result, which is insanely fast. It's still binary numbers, and you can display a binary number, but it's not gonna be particularly user-friendly if you have just a 16-bit number as an output. So obviously you want you know, your good old digits like that. And I've thought, okay, well, what if we just, so to display this number right here, we obviously use a 7-segment display. And the 7-segment display has 4 bits as inputs, and it's basically like binary coded decimal, right? So what that means is that, suppose we have like a number, I have 100. We want to encode number 100. So this will be our like first 7-segment display. This is our second 7-segment display, third and fourth 7-segment displays. And for example, we want to output 100. And how would you do that? Well, this is 0th place, obviously 100. On the 0 place we have like 0, so there's nothing here. Nothing here either. But here, that's a third 7-segment display. Well, we'll have a 1. And that will be 100 encoded using the binary coded decimal. Give another example, 1564. So we have in 4th place we have a 1. In 3rd place we have a 5, so this is a 5 in binary. In 2nd place we have a 6, this is 6 in binary. And in the 1st place, this 4, obviously it's a 4. So this is how 1564 will look like using binary coded decimal. And so I thought, yeah, we have this system. It's great for, like, you know, outputting and using 7-segment displays, the things that we're using right here. So I thought, yeah, why don't we just like go ahead and use it everywhere and just not use it for math as well? So I did this calculator, and it does exactly that. It uses binary coded decimal everywhere. So let me just crack that thing open. And as you can see, it's a bit actually useless because it's a mess. So let's actually, I'm gonna pull out a module that I've made, BCD, call it something like that. Yep, 1 digit. This is 1 digit, not 1 bit, 1 digit. So that's why you can see 4 bits, and there are 4 bits of output here, and the carry as well, right? Yeah, that's the carry, not this one. This is the carry. So, for example, we want to add, let's just, I guess, add a display somewhere. I guess this is the display. And because if we add like the maximum number that we can get here is 18, because 9 plus 9 is 18, obviously. So we're gonna have 2 7-segment displays. We're gonna connect them like that. And I'm just gonna demonstrate how that works, you know, why not? So the input I'm not gonna make 7-segment display for, because no use. And then the output is just this. This is the output. Connect the least significant bit to the least significant bit. And the rest we connect as follows. And we have a carry, which basically means that's just 5th bit. And we just plop that here, and here we have 0, 0. If you want to be quote-unquote fancy, we can do this. so that when we have this digit, well, when this digit outputs nothing, we can just go ahead and not output even a 0, so we'll have nothing and 0 like that. So right, we have that. And suppose we want to add 3. So this would be like our digit, like right here. Yeah. So add 3 plus 5. And what do we get? Right, it's 8. That's neat, pretty easy. Pretty simple, doesn't require any special logic, really. Let's add 9 plus 8. And as you can see, we get 17. And let's get 9 plus 9, get 18. Let's get, I don't know. What is it? 9 plus 7. We gotta get 16, which is correct. 9 plus 3, 12. As you can see, it works pretty well. And now we can just stack those together. And we can get something like this. 4-digit decimal adder. So as you can see, those carry outputs, those fifth bits, as well call them, I guess, they're connected to this carry in. So this yellow gate is carry in. And it connects to here. So we just connected these things together like that to form like 2-digit adder. So go ahead, connect this to here, and here we go, 2-digit adder. And we can really do this infinitely, but it will get progressively slower as because it's basically a ripple adder at this point. Honestly, the binary coded decimal, why is it so good? Why am I even like, why is it useful in any way? Well, because it's so ridiculously easy to just input numbers. And really, it's very precise, because the thing is, suppose we have like this awful number. If you're gonna try to encode this in binary, I'd imagine you don't have enough precision to encode it to like 100% correctly. Here you can just say, yep, the decimal pointer is right here, and that's it. And here we go, it just works, you know? Because we're using decimal, therefore decimal will just bloody work. It will be as easy as that. It's very precise. Like if I want to, I can add a decimal point right here, and it will be right here as well, and that's it. We've got our decimal point. It's as easy as that. So that's the cool thing. And another cool thing about the binary coded decimal addition, subtraction stuff is that we can just go ahead. So we want number 5,000. So this is the 5,973. Bam, we just inputted the number because it's literally just binary coded decimal. We encode decimal digits using binary. Pretty easy. And we go ahead and connect, for example, 3,700 and I don't know, 1. I forgot what the first one number was, but doesn't matter. And we're gonna get 9,674. 701. Those were the numbers that we've added, and this is correct. This is also correct. Kind of boring numbers actually I've picked, but doesn't matter. 7 plus 9, I don't know. And 5 plus 3, yeah, correct. So yeah, as you can see, it works flawlessly. So yeah, this is honestly pretty cool. The only thing that I haven't really thought about is how do we do multiplication? Multiplication is I bet, probably the finer part. And then the division, again, it's probably gonna be some horrid shit as it is in binary. Because... So... This is the division. And honestly, this sucks to make a lot. Because it's very slow. Division and binary sucks very much. And I'm pretty sure the same thing will be for binary coded decimal. I'm not sure how to do it even. So Yeah, that's a problem, I guess. So want to make long division. How? I don't yet know. But anyway, if you know how to make multiplication or division, or maybe even more fun stuff like, I don't know, square root or exponentiation or some shit, then you can comment down below, but I'm pretty sure no one will watch this, and so it doesn't matter. Anyway, enough ramblings. I'll see you next time. Sometime. Yes, goodbye.